So, good morning, welcome to Sakala Vidya educational channel. So, welcome to our engineering mathematics classes. So, we have been discussing problems on D'Alembert's ratio test. So, in the previous episode we have completed up to 9 problems. So, now we shall discuss from 10th question onwards. So, let us get started. So, now let us move to the 10th question now today. 10th question. Question number 10, right. So, note down the question number 10. Test the convergence of the following series. So, that is under that first one, sigma n cube plus a divided by 2 to the power of n plus a. So, this question was appeared in OSMANIA University, OU, May 2012. So, this was the previous examination question. So, it may be given in any university examinations also. So, first check it. This is in actually the 2 to the power of n plus a in the form of some 2 to the power of something form. So, then we need to apply D'Alembert's ratio test now. Here, because we cannot write in geometric test, we cannot apply. Even we cannot apply P test, and we cannot apply even comparison test. So, we go for D'Alembert's ratio test. So, already nth term is given. So, let us try to figure it out this question now. Solution. So, what is given actually here? Nth term un equals to n cube plus a 2 to the power of n divided by 2 to the power of n plus a. Now, first let us find out un plus 1 value. So, therefore, un plus 1. See, un plus 1 is equal to, in the place of n plus 1. So, n plus 1 whole cube plus a divided by 2 to the power of n, that is 2 to the power of n plus 1 plus a. So, now let us simplify un by un plus 1 value. This is equal to n cube plus a divided by 2 to the power of n plus a divided by n plus 1 whole cube plus a divided by 2 to the power of n plus 1 plus a. So, now we can simplify further like this. So, this is equal to, we can write n cube plus a divided by 2 to the power of n plus a multiplied with the reciprocal of the denominator. What is the reciprocal of the denominator? 2 to the power of n plus 1 plus a divided by n plus 1 whole cube plus a. So, now can you simplify? Let us see, let us check once again. So, from actually here you can take out n cube common from n cube plus a, n cube common, and also next from this one 2 to the power of n plus 1 take common here, 2 to the power of n plus 1 common. So, here also we can take n cube common from n plus 1 whole cube plus a. So, that means this can be rewritten as n cube plus a by n plus 1 whole cube plus a into 2 to the power of n plus 1 a by 2 to the power of n plus a. Let us write like this first of all. So, n cube plus a divided by n plus 1 whole cube plus a multiplied with 2 to the power of n plus 1 plus a divided by 2 to the power of n plus a. Clear? From actually the first factor, let us take n cube common from numerator. Similarly, n cube common from the denominator. So that means if you take n cube common, what do we get? N cube times 1 plus a upon n. A is actually constant itself only, a upon n, divided by, from n plus 1 if you take n common, n into 1 plus 1 by n whole cube, that becomes n cube times, we will get like this, 1 plus 1 by n whole cube. Clear? So plus a upon n cube, multiplied with 2 to the power of n plus 1, we can write 2 to the power of n into 2 to the power of 2, 2 to the power of n common, we get 2 plus a. Here 2 to the power of n common, 1 minute. So here carefully let us take out common. This 2 to the power of n plus 1 is 2 to the power of n into 2. 2 to the power of n common, we have 2 plus a upon 2 to the power of n divided by 2 to the power of n common, we get 1 plus a by 2 to the power of n. So now the simplification part, n cube got cancelled, 2 to the power of n got cancelled. Now you can apply the limit, right? Let us apply the limit. So now we are going to apply here by D'Alembert's ratio test. D'Alembert's ratio test. We are going to apply this dot ratio test. Then what do we get now? So limit n tends to infinity, un by un plus 1. So this is equal to, if you apply the limit for this one, what do we get now? As n tends to infinity, a by n tends to 0. So 1 plus a divided by 1 by n is also 0. 1 plus 1 whole cube 1 plus a by n cube is 0. So 1 plus 0 by 1 plus 0 multiplied with this will be a by 2 to the power of n. As n tends to infinity, 2 to the power of n is infinity, a by infinity is 0. So 2 plus 0 by here 1 plus 0. So obviously you will be getting actually here, see, 1 into 2, 2 by 1 into 1, 1. 2 you will be getting, which is greater than 1. So limit n tends to infinity, un by un plus 1 is equal to 2, which is greater than 1. So then the given series is actually, whatever given series, sigma un is convergent by D'Alembert's ratio test. It has been completed now, right? So now let us write our conclusion. So what is the conclusion that, so here what is the conclusion that, so therefore or hence sigma un is convergent. So let me explain once again, you check. Test the convergence of the following series. So sigma n cube plus a by 2 to the power of n plus a. This was given in OSMANIA University, May 2012. So here un is equal to n cube plus a by 2 to the power of n plus a. So first let us find out un plus 1, because it is consisting of some power, just like 2 to the power of n, 3 to the power of n, like that. So then we need to apply D'Alembert's test, ratio test itself only. So now un plus 1 is equal to, in the place of n, write down n plus 1. So n plus 1 whole cube plus a divided by, in the place of this n, write down n plus 1. So 2 to the power of n plus 1 plus a. Let us evaluate the value of un by un plus 1, that is equal to n cube plus a by 2 to the power of n plus a divided by n plus 1 whole cube plus a by 2 to the power of n plus 1 plus a. So now n cube plus a by 2 to the power of n plus a into reciprocal of this one, that is 2 to the power of n plus 1 plus a by n plus 1 whole cube plus a. So now you can separate it like this: n cube plus a by n plus 1 whole cube plus a into 2 to the power of n plus 1 plus a divided by 2 to the power of n plus a. From actually the numerator of this one n cube plus a, let us take actually n cube common. We get 1 plus a by n cube, and similarly from n plus 1 take n common. This is n into 1 plus 1 by n whole cube. So you will be getting n cube common, 1 plus 1 by n whole cube plus a by n cube into, in the similarly from this one actually this 2 to the power of n plus 1 we can write 2 to the power of n into 2, right? If you take 2 to the power of n common, we have 2 plus a by 2 power n divided by, from 2 to the power of n plus a, let us take 2 power n common, we get 1 plus a by 2 power n. 2 power n got cancelled, n cube got cancelled. So by D'Alembert ratio test, limit n tends to infinity, un by un plus 1. So 1 plus this will be 0, 1 plus 0 whole cube plus 0. So 1 plus 0 by 1 plus 0 into 2 plus a by 2 to the power of n also 0, 1 plus a by 2 to the power of n 0. So 1 into 2 by 1 into 1, that is 2, 2 is greater than 1. So therefore sigma un is convergent. I hope it's very clear. So let us move to the second question under 10th. Under 10th, let us move to the second question. That means second question now. Second question. So test the convergence of the given series, that is sigma n factorial 2 to the power of n by n to the power of n. So whenever it is consisting of factorial terms, so then we need to apply D'Alembert ratio test. For example, if you observe, it is not in the geometric series. Geometric series means 1 plus r square plus r cube plus and so on, r to the power of n form. No. If you want to apply the p test, that is actually sigma 1 by n to the power of p form. No. So next, it is not in the form of f of n by g of n, where f of n, g of n are the polynomials in n. F of n is less than g of n. So comparison test is not at all entertained. So go for D'Alembert ratio test. So let us start with the solution. Here nth term, let us write nth term. You can say let also, no problem. So un equals to n factorial 2 to the power of n divided by n to the power of n. Therefore un plus 1, let us find out un plus 1. In the un, in the place of n, let us write n plus 1. So n plus 1 factorial 2 to the power of n plus 1. This is n plus 1 all to the power of n plus 1. Clear? Right. Now let us find out un by un plus 1 form. So the value of un by un plus 1, let us evaluate. That is n factorial into 2 to the power of n by n to the power of n divided by n plus 1 factorial into 2 to the power of n plus 1, you can write 2 to the power of n into 2 divided by n plus 1 all to the power of n plus 1. Am I right? So next we need to simplify. So we need to simplify now. Right. Next, see how to simplify this one. This equal to n factorial into 2 to the power of n by n to the power of n. So multiplied with reciprocal of this one, that is n plus 1 all to the power of n plus 1. So by n plus 1 factorial into 2 to the power of n into 2. So 2 to the power of n, 2 to the power of n got cancelled. So now we have n factorial into n plus 1 all to the power of n plus 1, right, divided by What do we have here? Actually n square we have. Here n square we have, right? Not n square, this is, sorry, n to the power of n. This is n to the power of n. Wait a moment, wait a moment. This is n factorial into 2 to the power of n by n to the power of n into this one. So 2 to the power of n, 2 to the power of n got cancelled, right? So we have actually n factorial into n plus 1 whole to the power of n plus 1 divided by, what do we get now here, n to the power of n, right, into here n plus 1 factorial. N plus 1 factorial is shifting property, that we can write n plus 1 into n factorial into 2. 2 here we can write, no problem. See n plus 1, sorry, wait, we can write. See n plus 1 to the power of n plus 1 also we can write n factorial, right, this we can write n factorial into n plus 1 whole to the power of n, we can write n plus 1 whole to the power of n into n plus 1 divided by, this is 2 into n to the power of n plus 1 into n factorial. See n plus 1 got cancelled, n factorial got cancelled. We have 1 by 2 times n plus 1 by n plus 1 whole to the power of n by n to the power of n plus 1 by n whole to the power of n, you can write it. And this can be simplified as half times n by n is 1 plus 1 by n whole to the power of n. Right, now we need to apply D'Alembert ratio test. By applying D'Alembert ratio test, D'Alembert ratio test. So that means limit n tends to infinity un upon un plus 1. This is equal to, here half common constant, so limit n tends to infinity 1 plus 1 by n whole to the power of n. We have very beautiful formula, so that is nothing but, let me write the formula here. See, limit x tends to infinity, one of the standard results of the limits, limit x tends to infinity 1 plus 1 upon x whole to the power of x is nothing but e, where e is the actually base of the Napier's logarithms base, that is e. So that means now we are going to get like this, this one is equal to half times e, that is e upon 2. So now we need to check whether e by 2 is less than 1 and greater than 1. How do we check? Here see, e is actually lies in between 2 to 3. So e lies between 2 to 3. Divide by 2 throughout, 1 less than e by 2, e by 2 less than 1.5. Obviously e by 2 is the actually greater than 1 itself only. So greater than 1. So this is greater than 1. Since it is greater than 1, therefore sigma un is convergent. I hope you might have followed this one. You might have followed this question. So all of you go through it. Everything is I have done in only single page for your better understanding. Okay. Right. Sigma n factorial 2 to the power of n by n to the power of n. So here nth term un is equal to n factorial into 2 to the power of n by n to the power of n. So first let us find out un plus 1 is equal to, in the place of n replace n plus 1. So n plus 1 factorial 2 to the power of, in the place of n plus 1, 2 to the power of n plus 1 by n plus 1 whole to the power of n plus 1. This is un plus 1. Now un by un plus 1. So n factorial 2 to the power of n by n to the power of n divided by n plus 1 factorial 2 to the power of n plus 1, we can write 2 to the power of n into 2 divided by n plus 1 whole to the power of n plus 1. This we can write n factorial into 2 to the power of n by n to the power of n into n plus 1 whole to the power of n plus 1 by n plus 1 factorial into 2 to the power of n into 2. 2 to the power of n, 2 to the power of n gets cancelled. We have n factorial into n plus 1 whole to the power of n plus 1 by 2 into n to the power of n into n plus 1 factorial shifting property. So n plus 1 into n factorial. Again this n plus 1 whole to the power of n plus 1 we can write n plus 1 whole to the power of n into n plus 1. So now this we can write n factorial n plus 1 whole to the power of n into n plus 1 by 2 into n to the power of n, n plus 1 into n factorial. Here n plus 1 got cancelled, n factorial got cancelled. Half common, n plus 1 whole to the power of n by n to the power of n is n plus 1 by n whole to the power of n. So this we can write half into n by n is 1 plus 1 by n whole to the power of n. By D'Alembert's ratio test, limit n tends to infinity, un by un plus 1 is equal to, here half is constant, taken common out. So apply the limit to the only this function, only up to this function itself only, here to here, right. So half into limit n tends to infinity 1 plus 1 by n whole to the power of n. It is one of the standard results. Limit n extends to infinity 1 plus 1 by x whole to the power of x is equal to e. So that means half into e by 2. We need to check whether e by 2 is less than 1 or e by 2 is greater than 1. As e value is 2 point something, it lies in between 2 to 3. Divide both sides, divide throughout by 2. So 1 less than e by 2 less than 1.5. Obviously e by 2 is greater than 1. So therefore sigma un is convergent. I hope it's very clear to you. So this is the question now, 10th question, and also we have completed. Let us move to the next question number 11. Question number 11. Let us move to question number 11. Are you ready? Question number 11. Okay. Write down. Discuss the convergence. Discuss the convergence of the series sigma n factorial by n to the power of n, right. So as it is consisting of, it involves n factorial terms, we need to apply D'Alembert's ratio test. Okay, let us apply and try to figure it out, this question now. Right, see the solution now. Here nth term is given, so here un equals to n factorial by n to the power of n. Now therefore let us find out un plus 1. In the place of n, let us write n plus 1. So n plus 1 factorial. So divided by n plus 1 whole to the power of n plus 1. Right, this n plus 1 factorial we can write n plus 1 into n factorial. We can simplify here only, no problem. This n plus 1 whole to the power of n plus 1, for our convenience we can write n plus 1 whole to the power of n into n plus 1 write down. Clear? So now what we need to do, we need to evaluate the value of un divided by un plus 1. So that is equal to un is n factorial by n to the power of n divided by n plus 1 whole to the power of n 1 minute. That is actually n plus 1 into n factorial by n plus 1 whole to the power of n into n plus 1, right? So next what shall we do now? Let us simplify it. So this is equal to n factorial by n to the power of n multiplied with reciprocal of this value. So n plus 1 whole to the power of n into n plus 1 divided by n plus 1 into n factorial. See, n factorial got cancelled. N plus 1 got cancelled. We have n plus 1 whole to the power of n by n to the power of n. So we know that one beautiful formula in powers and exponents, a to the power of n by b to the power of n is there. This we can write a by b whole to the power of n. This form we can write. So with the help of this one, now this we can write n plus 1 by n whole to the power of n, right? This we can write n by n is 1 plus 1 by n whole to the power of n. So now you need to apply, right? You need to apply by D'Alembert's ratio test. D'Alembert's ratio test. Let us apply. So what does mean by D'Alembert's ratio test? That means limit n tends to infinity un by un plus 1. So limit n tends to infinity un by un plus 1 is 1 plus 1 by n whole to the power of n. So already in limits we have studied one of the standard results. Limit n tends to infinity 1 plus 1 upon x or 1 by x whole to the power of x is equal to nothing but e. So this is equal to, what do we get now here? This is equal to e. Here where e lies between 2 to 3. 2 less than e, e less than 3. Obviously e will be greater than 1. Therefore sigma un is convergent. Clear? You might have understood this question. 11th question. Yes, you might have understood this question now. Yes or no? Right? Okay, let me explain. Discuss the convergence of the series sigma n factorial by n to the power of n. So here un is equal to n factorial by n to the power of n. So first let us find out un plus 1. In the place of n plus 1, n plus 1, n plus 1, n plus 1 factorial by n plus 1 whole to the power of n plus 1. N plus 1 factorial we can write n plus 1 into n factorial divided by this we can write n plus 1 whole to the power of n into n plus 1. So let us try to evaluate the value of un by un plus 1. So un is nothing but n factorial by n to the power of n divided by n plus 1 into n factorial by n plus 1 whole to the power of n into n plus 1. So it can be simplified further. So equals to n factorial by n to the power of n into n plus 1 whole to the power of n into n plus 1 divided by n plus 1 into n factorial. N plus 1 got cancelled. N factorial got cancelled. We have n plus 1 whole to the power of n by n to the power of n. As we have a to the power of n by b to the power of n is equal to a by b whole to the power of n. This we can write n plus 1 by n whole to the power of n. So this can be simplified. N by n is 1 plus 1 by n whole to the power of n. So by D'Alembert's ratio test, limit n tends to infinity un by un plus 1, that is equal to limit n tends to infinity 1 plus 1 by n whole to the power of n. So using one of the standard results, limit n tends to infinity 1 plus 1 by x whole to the power of x is e. So our answer is also e, where e lies between 2 to 3. Obviously e is greater than 1. So sigma un is convergent. So let us move to the 12th problem. 12th problem. Discuss the convergence of the series. The convergence of the series sigma root n divided by root over n square plus 1 into x to the power of n. So what is the nth term of this series? What is the nth term of this? Nth term of this series is root n by root over n square plus 1 x to the power of n. The nth term is consisting of x to the powers of x. Obviously we need to apply dot only. That means actually here D'Alembert's ratio test. Okay, let us proceed for our solution now. Solution. Here un equals to nth term, un equals to root n divided by root over n square plus 1 into x to the power of n. Now therefore let us find out un plus 1. This is very important problem. This question is very important problem. All of you concentrate. So this is equal to root over n plus 1 and root over, what do we get? N square means n plus 1 whole square and plus 1 into x to the power of n plus 1. So let us simplify further this one also. This is equal to root of n plus 1 divided by root of, this we can write n plus 1 whole square means a plus b whole square formula, a square plus 2ab plus b square. We can write n square 2n plus 1 that is nothing but plus 2 into x to the power of n plus 1. You can write x to the power of n into x, you can write. So now you need to find out, here you need to find out un by un plus 1. Let us simplify. Un by un plus 1 is equal to root n by root of n square plus 1 into x to the power of n multiplied with, sorry, 1 minute. First un plus 1 we need to write. Un plus 1 we need to write. Divide by root of n plus 1 by root over n square plus 2n plus 2 into x to the power of n into x. See, x to the power of n got cancelled. So this for our convenience we can write this is root of n by n square plus 1 into reciprocal of this. Reciprocal of this means you can write root of n square plus 2n plus 2 by, you can write n plus 1 into 1 upon x, you will write it 1 upon x. Root a into root b, root of ab you can write. This is equal to root of, otherwise actually you can do one thing, this we can write root of this n into n square plus 2n plus 2 into n square plus 1 into n plus 1. This we can modify like this, n upon n plus 1 or n divided by n plus 1 into, we can write n square plus 2n plus 2 by n square plus 1. Just we can modify like this. into 1 upon x. This is un by un plus 1 value. I have written n by n plus 1 into n square plus 2n plus 2 by n square plus 1. That's all. So further it can be simplified as, actually here you can take n common. This is 1 plus 1 by n you will be getting. Here n square common. So let us do it now. So this is equal to, you can write root over n by, here n common, 1 plus 1 by n. Here n square common, 1 plus 2 upon n plus 2 upon n square by n square common, we have 1 plus 1 upon n square into 1 upon x. Clear? Right, this you will be getting now. So next we need to apply D'Alembert ratio test now. You need to apply the limit. When you apply the limit, what happens now? N got cancelled, here n square got cancelled. 1 by n is 0, 2 by n is 0, 2 by n square is 0, 1 by n square is 0. This is root 1 is 1. Obviously you will be getting 1 by x. So let us write in the next page. So now you will take this one here to the next page. Right, this is the next page you will be getting. This is the value, actually un by un plus 1 value. So what happens now? Here n square got cancelled, n got cancelled. So by D'Alembert's ratio test, right. So limit n tends to infinity, un by un plus 1. This is equal to limit n tends to infinity, root of 1 by 1 plus 1 by n into 1 plus 2 upon n or 2 upon n square divided by 1 plus 1 upon n square into 1 upon x. So now this 1 upon n, 2 upon n, 2 upon n square, 1 upon n square 0, root over you will be getting 1 upon 1 plus 0 into 1 plus 0 plus 0 by 1 plus 0 into 1 by x. Obviously you get this will be root of 1 by 1, root 1 into 1 upon x. This will be 1 by x. So we cannot say that 1 by x is greater than 1, 1 by x is less than 1, or 1 by x is equal to 1. So that means when 1 by x is greater than 1, it is convergent. When 1 by x less than 1, it is actually divergent. When 1 by x is equal to 1, it test fails. So that's why here 3 cases are to be discussed. Very clear manner we need to discuss. So now let us write now the cases. The cases will arise. Next we need to discuss. First write down. What are the cases will arise? If 1 by x is greater than 1, that is x less than 1, then sigma un is convergent. It converges. Suppose if 1 by x is less than 1, that is x greater than 1, then sigma un is divergent. When 1 by x is equal to 1, that is x is equal to 1 by cross multiplication. Test fails. When test fails, it may converge or diverge. That we need to test. Now again we need to go for geometric test or comparison test or next, otherwise we need to go for comparison test itself only most of the cases. So now consider x is equal to 1. If you put x is equal to 1, un becomes, what is un? Nth term. So here nth term is nothing but actually what? That is root n by root of n square plus 1. N square plus 1 into x to the power of n, that is 1 to the power of n, you get root n by root of n square plus 1. So now the root n, degree of root n is 1 by 2, the degree of this one is actually 2 by 3. So that means actually what we need to do now here, so we need to choose Vn. How to choose the Vn? Here actually root n as it is, you keep it up. From root of n square, take n square common, n common out, n by under root of 1 plus 1 upon n square you will be getting. So root n by n, this we can write root n divided by this n, you can write root n into root n into root of 1 plus 1 upon n square. This root n got cancelled. We have actually 1 by root n into root of 1 plus 1 by n square. This, let us choose 1 by root n as auxiliary series as a actually Vn now. Choose Vn equals to 1 upon root n. So by comparison test, again we need to apply the comparison test. By comparison test. So what do you mean by the comparison test? Limit n tends to infinity un by Vn. So limit n tends to infinity. So un is nothing but actually 1 by root n into root of 1 plus 1 by n square divided by Vn. Vn means 1 by root n. So this 1 by root n gets cancelled. We have 1 here. Apply the limit. What do you get now? 1 by root of 1 plus, as n tends to infinity, 1 by n square is 0. So 1, which does not equal to 0. So therefore we conclude that this one, so it is concluded that, so therefore sigma un or sigma Vn diverges or converges, sigma un converges or diverges as sigma Vn converges, diverges. So that means actually here does not equal to 0. So what do we write now here? Sigma Vn is convergent. Okay. How to test the convergent? Actually here see Vn 1 by root n, this we can write 1 by n to the power of 1 by 2. This is comparing with 1 by n to the power of p. So here p is equal to 1 by 2. So 1 by 2 is what now? Less than 1. So 1 by 2 is less than 1. Therefore sigma Vn is divergent. Sigma Vn is divergent by p test. Clear? That we need to write here. So as it is divergent, this is also sigma un also divergent. Sigma un is also divergent. That means when x is equal to 1, sigma un is divergent. When x greater than 1 also divergent. So now we need to conclude these two statements as a single statement now. So if x less than 1 or sigma un is convergent when x less than 1, sigma un is divergent when x greater than or equal to 1, that we need to conclude, that the final statement. So that we need to write it now. So hence sigma un is convergent when x less than 1, when x less than 1, sigma un is divergent when x less than 1 or and x is equal to 1, x greater than or equal to 1. Go to x greater than 1 divergent, equal to 1 also see divergent. So x greater than 1. So like this we need to conclude this is very very important, you must remember this one. So the series is the sigma un is convergent when x less than 1, sigma un is divergent when x greater than or equal to 1. Okay, so let us go to question once again. Right, so let us discuss once again. Discuss the convergence of the series sigma root n by root of n square plus 1 x to the power of n. When it is consisting of the x to the power of n term, it involves x to the power of n term. So we need to apply D'Alembert ratio test. First, here un is equal to root n by root of n square plus 1 x to the power of n. Let us find out un plus 1 is equal to, in the place of n, write down n plus 1, root of n plus 1 by root of n plus 1 whole square plus 1 into x to the power of n plus 1. This is root of n plus 1 by root of n plus 1 whole square plus 1, n square plus 2n plus 1 plus 1, n square plus 2n plus 2. This x to the power of n plus 1 we can write x to the power of n into x. So now let us find out un by un plus 1 value. So root n by root of n square plus 1 into x to the power of n by root of n plus 1 by root over n square plus 2n plus 2 into x to the power of n into x. X to the power of n, x to the power of n got cancelled. This we can write root of n by n square plus 1 into reciprocal of this root of n square plus 2n plus 2 by n plus 1 into, this is actually 1 upon x, separately write down 1 upon x. This is root over again n by n plus 1 one side, n square plus 2n plus 2 by n square plus 1. So next what shall we do means, actually here from n plus 1 let us take n common, n into 1 plus 1 by n by n into 1 plus 1 by n. Here n square plus 2n plus 2, take n square common, from n square plus 1 take n square common, n square into 1 plus 2 by n plus 2 by n square divided by n square into 1 plus 1 by n square. Now what happens now here, n got cancelled, n square got cancelled. So next step we have, see next step we have here, this is root of, actually we have 1 by 1 plus 1 by n, 1 plus 2 by n plus 2 by n square by 1 plus 1 by n square into 1 by x by D'Alembert ratio test. D'Alembert ratio test. D'Alembert ratio test. This is limit n tends to infinity un by un plus 1, limit n tends to infinity root of 1 by 1 plus 1 by n into 1 plus 2 by n plus 2 by n square divided by 1 plus 1 by n square into 1 by x. Applying the limit, 1 by n is 0, 2 by n 0, 2 by n square 0, 1 by n square 0, 1 by 1 plus 0 into 1 plus 0 plus 0 by 1 plus 0. This will be root 1 into 1 upon x. Separately this one let us write once again, root of 1 into 1 upon x, that will be 1 upon x. This is very very important. Now the three cases will arise. So what are the three cases? If 1 by x is greater than 1, that is x less than 1, sigma un is convergent. When 1 by x less than 1, that is x greater than 1, sigma un is divergent. So when 1 by x is equal to 1 or x is equal to 1, test fails. When test fails, you need to substitute x is equal to 1 in the un. We get root n by root of n square plus 1, 1 to the power of n, root n by root of n square plus 1, root n by, here take n square common means you will get n, root n by, this n we can write root n into root n, 1 by root n into root of 1 plus 1 by n square. So that means actually this is f of n by g of n. Degree of f of n is less than degree of the, actually here what do we have? Denominator. We need to apply the comparison test. So first for comparison test, either geometric test or p series, auxiliary series we have to select 1 by root n. So this is sigma 1 by root n is the auxiliary series. Choose Vn, nth term of that one, 1 by root n, 1 by n to the power of 1 by 2, that is 1 by n to the power of p. Here p is equal to 1 by 2, which is less than 1. Sigma Vn is divergent by p test. So that means by comparison test, what do you say? So that means sigma un is converges or diverges as sigma Vn is converges diverges. That means you need to apply the comparison test. So comparison test means un by Vn, limit n tends to infinity, 1 by root n into root of 1 plus 1 by n square divided by Vn, 1 by root n, 1 by root n, 1 by root n gets cancelled. Apply the limit. So here 1 by n square is 0, 1 by root of 1 plus 0, 1, that does not equal to 0. Therefore, as sigma Vn is divergent, sigma un is also convergent. That's why here we need to write one more statement, as sigma Vn is convergent, sorry, divergent. That means when x is equal to 1, it is divergent. So now what shall we do now? We need to conclude these two statements at a time. Sigma un is convergent when x less than 1. Sigma un is divergent when x greater than 1 and also x is equal to 1. Both we need to include. So final statement we need to write. That is, hence sigma un is convergent when x less than 1. Sigma un is divergent when x greater than or equal to 1. Hence the problem has been solved. So we shall solve some more problems on DLMS test itself only, because it's very, very important. We shall do some more interesting problems in the next class. Thank you. Bye bye. Have a nice day.